I'm going to take you a different journey. We talk about industry 5.0, but which are the applications going to get to that, what are the pros and cons. So little bit of journey on EV side. I was fortunate to work with Stan during my earlier work. At the age of 97, won the Nobel Prize for the lithium-ion batteries in 2019. Then Akira and Stan, unfortunately good enough, passed away few months back. Excellent innovation done in 1980s, where we use in mobile phones to everything on lithium-ion battery. To get you few technological development on the energy side. So mainly after the innovation of the lithium iron phosphate, we call lithium-ion battery. It come up with its own journey from Sony, then different companies build the batteries. The new technology, we studied the periodic table in school in standard 10, and people are playing now with different materials to see we have a lot of dependency on our neighboring country for getting the lithiums and other raw materials. And over the years, these are the technological evolution happening. Then one is people are calling, I used to work on lithium air battery. It's nice to have take the oxygen from air, and that energy density is close to petrol or diesel vehicle. But there are a lot of still fundamental challenges to go further. Lead acid battery still remain, lead acid and polymer, plastic, if you ask me, they will remain, still the human race is there. But with the new evolution on the sodium ion and other parts can close to the lead acid in terms of the cost and the reliability, safety in terms of the lithium ion battery. So these are some of the things which people are working on. Just to get the idea what is there. So this is 18650 used by Tesla earlier in their vehicles, and that journey. Those who are not familiar with the batteries, 18650 is like a cylindrical cell, same like we have in our remote for the TV, bigger 18 mm and 65 mm length and height. Like that evolution happened. In a smaller volume, you get more and more energy density. So 4680 is a new number which is patented by Tesla and using in the vehicles. But other form factors like these are cylindrical cells. One is in the middle, prismatic cells used by BMW, made by Samsung and other companies. Then pouch cell, mainly used in, developed by LG, A123 and so on. But used in the Renault Nissan and many other companies. Just to get idea why we are talking this. Consider this is a box with the batteries. I'm trying to show the video. Is it working? Can you? Yeah. Sorry, these are the number of cells. Yeah, it's working. These are the cold plates, connectors, and there is a wiring harness, high voltage, low voltage. So battery pack consists of lot of chemistry, lot of mechanical, lot of electrical. I am a chemist, I am not an engineer. But you build this, you need to have the connecting the dots. And where our industry 5.0, cobot, smart manufacturing plays a very, very important role. And these manifolds, this is a big bomb. You have to handle it carefully. So safety play a very, very important role. And again, back to periodic table, like we say Coca-Cola formula or Maggi formula, unique. Similarly, each company has their own recipe to build its batteries, whether it is the binder, solvents, and different permutation of combination, design of experiments, choosing the right raw material, right supply chain, make this battery. So these combinations with different sizes. These are the standard processes. We studied anode and cathode and separator in standard 7 and 8. going back to school, and then build different type of materials which are used in our all the vehicles, say in automotive as well as for stationary storage. And this is very interesting journey, like you see combustion engine, 150-year-old technology, still catches fire because it's evolution. Lithium-ion battery, few years back, coming into a picture, it's evolving, and per kilowatt is the unit, your battery kilowatt unit, based on that your range is decided, and based on that over the globe people use the different hybrids, micro hybrid, plug-in and so on, and then come to the complete electric vehicles where you can skip and use complete battery operated vehicles. To build these systems, say for the battery side, this is one of the application of the smart manufacturing. There are various types of the factors which can lead to that. This is available, you can find out, but why we use this? Because these are all connecting dots to help us to build a sustainable, safer product, which includes the evolution from industry 1.0 to 5.0, where it is not only limited to the certain specific geography, but because of this industrial 5.0, there is a lot of evolution happen, like these are the standard where in industry 4.0 we use with the focusing with the connecting the mechanics, but on the other hand it is like a Dell laptop. Nowadays, to give an example, like industry 5.0, not only with building the batteries, but also say I need with my, I am a marathon runner and I wanted to run certain kilometers. Based on that, I go to the shop, design based on my health index and all that, design my shoes. For that, I use this technology. So like that, day-to-day life, to go from Mars and other appliances, we use all type of application to have your manufacturing more easier. From people are going to talk later on blockchain, drones and other technologies, and these evolution happen on mass personalization, where Vikas has spoken earlier on the different topics, where we all are familiar with strategy, right goal, but one of the key thing is it's a balance with the technology. I have Alexa at home, but who is going to give the command? I remember, just to give you one example, few years back we gone to the family event for Satyanarayan Puja, and me and my wife are hosts there, and then on Alexa there is one music stotras going on, and my son was not aware, and he directly came, he was directly mentioned to Alexa, start Kala Chashma, and everybody was shocked, "Arey, ye kya chalu hai?" But these are the transformation through Alexa. Earlier we used to write many other things, but now in a right way how you use the technology is very, very important. And as he mentioned, the agility and sustainability, and again the other problem in overall is the skill people is the big challenge, and supply chain. I think many of the people agree when I'm saying the supply chain, there are a lot of applications from MRI to improve the technology, from smart GPI and all that thing, and how we conclude that with, when I said the cloud manufacturing, that means the product that we use, it coming from the different parts of the world. And in my world, say in the EV, we have a dependency with our great neighboring country, and we can't deny that, because raw material, mines, they have their control. But how we can use this technology to have a cost-effective, safer, sustainable product, that's the one of the key. And by using this tool, for example, because in the battery domain, you have a clean room environment, where your material coming from the Ghana or in the say Cuba, where the raw material, lithium or cobalt or graphite, this is just one example, is very important. But in the defense domain, if you want to make your product for defense, you can't use our neighboring country product because that is unwritten rule. So you have to look for the other country where they are manufacturing the raw material, which can constitute my overall battery. So this interdisciplinary, intercontinental product has to control, monitor in a such a way that we can design the product which is safer, which give me a flexibility in terms of the customized size, and which I can use for various applications over the geographies. And for that there are several parameters people are going to talk, whether it is digital twins, 6G, 5G, then blockchain, then IoT. For example, people talk about big data. There are going to talks. For example, I am giving one localized thing, like if I wanted to go from electric bus from Pune to Mumbai, I have generated more than say 200, 300 million kilometer data in Indian condition for my EV. How to use this big data is very important, and how to make the business out of it. I have a big data. To give up one example, at which position I have to place my charger, big data will help me. If I am driving the vehicle in say Guwahati, where there is a condensation, humidity, or in Chennai or in Leh Ladakh with the electric vehicle, this big data will help the placement of the chargers, or where there is a failure at high altitude and high humid condition, or in a flood. So this is the different connecting dots will help to give the right solution. Then key enabling technologies with different factors. COVID taught us many other things. You can find out these things on net. Then quantum computing, metaverse, and all is all to give the good sustainable product. Then some key areas where the smart manufacturing plays a role, where how we can use the sensors, actuators, or real time the maintenance, supply and sense, then twin, and so on. And by using this thing in my company, we use all this technological framework to make the product. It's a old group, mainly with the extrusion machines we build as a Colside group. We have two listed companies. One is Cabra Extrusion and one is Plasbins. We have more than 100 plus battery packs on the field on two-wheeler. We build customized battery packs. You can welcome to visit our manufacturing plant in Chakan. And with the high voltage system, battery packs for the commercial vehicles as well as for the LCVs. We have our own battery management system. In battery pack, there is an intelligence system for brain called the battery management system, and heart is the cell battery packs. And there is a new technology coming up where cell to pack or blade technology from BYD and many others. And we manufacture that thing in India, in Pune, by using the different tools. So thank you for attending, and we can discuss any questions later on.